It's coming, silent, invisible, and hungry. A rogue black hole is drifting through space, and it might be heading straight toward Earth. It emits no light. It can't be seen with the naked eye, yet it has the power to swallow entire planets without leaving a trace. So how do we even know it's out there? How did scientists detect a threat that doesn't shine, doesn't reflect, and doesn't make a sound? And the biggest question of all, what happens if it gets too close? Imagine space as a vast cosmic ocean, and drifting across that ocean are invisible, solitary, and utterly lethal predators. They don't emit light, don't reflect anything, and don't belong to any constellation. These are rogue black holes, cosmic ghosts silently roaming the universe. Their existence was, until recently, just a theory. Now, it's a terrifying certainty. It all begins with the collapse of a massive star. When these giants reach the end of their life cycle, they explode in a cataclysmic event, a supernova, which in some cases gives birth to a black hole. Normally, that black hole stays put, bound by gravity to the stellar system it was born in. But sometimes, the story takes a different turn. In extreme scenarios, the force of the explosion or dynamic interactions around the star can be so intense that the black hole is flung into space, fast enough to escape even the pull of its home galaxy. It's expelled, abandoned, and begins to wander. These cosmic outcasts can form in different ways. One likely scenario involves binary systems, two massive stars orbiting each other. If one goes supernova and turns into a black hole, and the explosion isn't perfectly symmetrical, the imbalance can literally catapult the black hole out of the system. Another possibility: when galaxies collide, the supermassive black holes at their centers can get caught in chaotic gravitational battles, and one of them might be ejected, as if the galaxy itself spat it out. Once free, these black holes travel across immense distances at staggering speeds, some reaching hundreds of kilometers per second. And the worst part? They're almost undetectable. Since they don't have active accretion disks, the glowing matter spiraling in, they don't emit radiation we can see. The only way we know they're there is through their gravitational effect on light passing near them, a phenomenon called gravitational microlensing. And it was through this effect that in 2022, scientists detected the first isolated rogue black hole drifting between the stars of the Milky Way. Light from a distant star bent ever so slightly, revealing the presence of a massive, invisible object, silent and utterly alone. Calculations showed it had about 7 times the mass of our Sun, and it was relatively close, just 5,000 light-years away. A giant leap for science, and a quiet warning for the future, because if there's one, there are more, and current models suggest there could be millions of them in our galaxy alone. That's right, millions of rogue black holes, wandering aimlessly between stars, between systems, maybe even between galaxies, each one a potential threat. Not because they're hunting. Black holes don't chase anything, but because they never stop moving. And if one happens to cross paths with a planet, disaster is inevitable. Now think about it. These objects are not static. They move. And we have no way of knowing exactly where they all are. It's like driving down a highway with invisible trucks coming straight at you. Some scientists believe studying rogue black holes can teach us a lot about how galaxies form and evolve, about the extremes of gravity, and even about dark matter. But at the same time, this knowledge carries a darker side. The possibility, however remote, of a direct encounter with one of these cosmic drifters is something no planetary system is truly prepared for. And the scariest part of all? Rogue. Black holes don't shine, don't announce their arrival, and leave no trace. They just pass by. Trying to detect a rogue black hole is like trying to hear a scream in a vacuum. They don't shine. They make no sound. They have no visual presence. They're just there. But it's as if they're not. And that's exactly what makes them so terrifying and so fascinating. But science has never accepted the invisible, and it was that obsession with the impossible that gave birth to one of the most brilliant tools in modern astrophysics: gravitational microlensing. Here's how it works. Imagine you're watching a very distant star. If a rogue black hole passes right between you and that star, its intense gravity will bend the fabric of space around it, like a heavy ball pressing down on a trampoline. As the star's light travels past that invisible mass, it's curved, magnified, and slightly distorted. For a brief moment, the star appears to shine brighter, with no clear reason. That's when astronomers leap into action. This phenomenon, predicted by Einstein over a century ago, allows us to detect something massive, dark, and compact, even if we can't see it directly. But the challenge is huge. The odds of that perfect alignment happening are incredibly slim. And yet, in 2022, it happened. For the first time ever, we detected a rogue black hole, isolated in space, thanks to gravitational microlensing, a historic breakthrough. But catching that weird flash of light isn't enough. To confirm it's really a black hole, and not just a faint star or a brown dwarf, astronomers use another technique, astrometry. They precisely track how the background star's position shifts over time. A tiny deflection in the light's path, caused by the gravity of the invisible object, confirms the culprit. And that's how, after months of data, NASA confirmed it. That dark object was, without a doubt, a rogue black hole wandering across our galaxy. Now enters one of the key players in this story, the Hubble Space Telescope. It was Hubble that managed to measure that tiny shift. Even after more than 30 years of service, Hubble remains one of the most precise instruments we have for zooming in on the cosmos. Without it, this discovery wouldn't have happened. But the future of hunting rogue black holes lies elsewhere. With the upcoming Nancy Grace Roman Space Telescope, scheduled to launch in 2027, its field of view will be 100 times wider than Hubble's, and it'll be able to monitor millions of stars at once. That means we could discover dozens, maybe even hundreds, of these hidden black holes scattered across the Milky Way. Another game-changing telescope is the Vera C. Rubin Observatory, which will scan the entire night sky, night after night, in ultra-high resolution. It'll track even the tiniest changes in stellar brightness with unprecedented precision, helping us catch more gravitational microlensing events in action. Science is finally building the right kind of eyes to see what was never meant to be seen. Still, every detection is a race against chance, a game of patience, precision, and a bit of luck. And the most mind-blowing part? Most rogue black holes are still completely off our radar. What we've found so far is just the tip of the iceberg. There are millions of them drifting through the dark, and most will never be found. But with every new telescope, every new mission, we get closer to spotting one more of these cosmic phantoms, silently crossing the universe. Imagine a rogue black hole drifting through space, invisible and silent, until one day it crosses the path of a solar system, like ours. What would be the real consequences of such an encounter? Would Earth be in danger? Or could the gravitational pull of these cosmic wanderers drastically alter the order of the planets? Let's find out. First, it's important to understand that black holes, even rogue ones, vary greatly in size and mass. Some may have a few times the mass of the Sun, others millions or billions of times more. This variation makes all the difference in the impact they would cause when passing near a planetary system. When a rogue black hole approaches a solar system, its intense gravity starts pulling not only planets, but also comets, asteroids, and even the dust and gas disk that may surround the central star. This effect can destabilize orbits that have been stable for billions of years, triggering collisions, ejecting planets into interstellar space, or even causing them to spiral into the star. In the case of our solar system, a rogue black hole passing very close could disturb the orbit of Earth and other planets, causing extreme climate changes and unpredictable impacts on life. However, the chances of such a close encounter are extremely low. Space is vast, and these wandering objects are spread across huge regions. Still, the effects don't have to be catastrophic to be felt. A simple increase in gravity could cause clouds of comets from the Kuiper Belt or the Oort cloud to be displaced, sending a rain of objects toward the inner solar system. This would already represent a real danger, with the possibility of huge impacts on planets and moons. Additionally, Rogue black holes can also interact with the system's central star. Depending on their mass and distance, gravity can cause the star to wobble, affecting the light and heat it emits, which in Earth's case could alter the climate and habitability. Some computer models indicate that if a stellar mass black hole passed about 1 light-year from our Sun, its influence could be felt but wouldn't be fatal. However, if it came within a few thousand astronomical units, orbital instability would already be significant, with drastic changes for the planets. So far, there are no confirmed records of rogue black holes crossing our solar system, but scientists remain alert to subtle signs that might indicate a nearby presence, such as perturbations in the orbits of distant objects or unusual radiation emissions. Ultimately, what makes these black holes so frightening is not just the possibility of destruction, but the difficulty in detecting them before they get too close. Without their own light emission, they are practically invisible, and we only know of their existence through the influence they exert on their surroundings. Understanding the potential impact of these cosmic visitors is crucial, so that in the future, we can develop alert systems and strategies to protect our planet. The search for rogue black holes continues, with increasingly powerful telescopes, like the James Webb itself, helping us map space in unprecedented detail. NASA confirmed something incredible: a rogue black hole completely alone, drifting through our galaxy at an insane speed, about 160,000 kilometers per hour. To put that into perspective, that's nearly 130 times faster than a speeding bullet. And yes, it's heading in our general direction, but don't panic just yet. It's still thousands of light years away. This lonely black hole was detected thanks to the Hubble telescope, using a method called gravitational microlensing. In other words, they didn't see the black hole directly. They saw how it bent the light of background stars, like a living lens moving across space. What's truly fascinating is how it ended up like this, rogue and isolated. Scientists believe it was kicked out of its original galaxy after a supernova explosion, or possibly after a chaotic merger between two black holes. Yes, space can be just as wild as it sounds. Despite its terrifying speed, this black hole poses no direct threat to Earth. Still, it's being closely monitored by astronomers around the world who are tracking its path and any potential impact. More than a danger, it has become a rare opportunity to study the behavior of solitary black holes, these ghostly wanderers drifting invisibly through a universe we still barely understand. Yale telescopes, like the James Webb itself, helping us map space in unprecedented detail. If you want to keep diving into the mysteries of space, from rogue black holes to the edge of the observable universe, make sure you subscribe, leave a like, and share this video with someone who loves a good cosmic mystery. See you in the next journey through the stars.